Okay, moving on. Now we're going to take a look at factoring some special trinomials. Sometimes you'll run into things that don't look exactly like the standard trinomial. For example, this one has a y here on the end. The easiest way is to start by worrying about the numbers and then making sure you've got all the y's in the right spot. So here we want numbers that multiply to 15 and add to positive 8. So I would think 3 and 5. If I have plus 3 and plus 5, those will add to 8. So I'm going to start with x plus 3 and x plus 5. But now I know that my last term has to be y squared. So I'm going to extend my brackets a little bit and add on y's. So now I've got x plus 3y, x plus 5y. If I expand that, I'll get my correct terms. Let's look at another example here. So I'm still starting with my numbers. So multiplying to positive 12, adding to positive 7. Hopefully you're starting to see the pattern in that this would be x plus 3 and x plus 4. Now I need my y's on, so I'm going to add those in at the end. Y and y. If I were to expand that, I would get x squared plus 4xy plus 3xy. That would be my 7xy. And then my last term is going to be 12y squared, which is what I'm given in the original question. Okay, next question here. So I'm going to start again with my number. So I'm looking for two numbers that multiply to 40 and that add to 14. So let's look at what multiplies to 40. We've got 1 and 40. Nope, that's not going to work.
Sorry, this is not supported.
2 and 20. Also not going to work. 4 and 10. Well, that one's going to work. We need positive 4 and positive 10. So we've got x plus 4y and x plus 10y. Moving on to our next one, looks again a little bit different. Now we've got x squared, y squared right at the beginning. We're still looking, here we've got something a little bit different. What I'm just going to do is let c equal xy. That means that I can rewrite my expression like this, c squared minus 10c plus 24. Now it looks like a regular trinomial to factor. I'm looking for two numbers that multiply to 24 and that add to minus 10. So let's think about what I have that multiplies to 24. 1 and 24, 2 and 12. Possibility, does that work? If I have minus 12 and positive 2, that does add to minus 10, but it doesn't multiply to positive 24. So let's keep going. I've got 3 and 8, does not add to 10. Then I've got 4 and 6. That can add to minus 10 if I have minus 4 and minus 6, which multiplies to positive 24. So now I can write my expression as c minus 4 times c minus 6, but I know that c is really xy, so then I can put my original main variable. For this last special trinomial here, I'm going to use an example that I used earlier on. The first thing that I'm going to do is factor out negative 1 so that I can write my positive x back at the beginning, plus 8x squared y minus 20y squared. Then I'm going to do the same thing I did in example D. I'm going to let c equal x squared. So then my trinomial becomes minus c squared plus 8cy minus 20y squared. Now, it's like the original special trinomial that I did. I'm looking for a number that multiplies to minus 20 and that adds to positive 8. So multiplies to minus 20, I could use 10 and 2 as long as 10 is positive and 2 is negative. So I can factor this as c plus 10y times c minus 2y. Now I know that c is really x squared, so I can replace my c's with x squared to get my fully factored equation. The next part here, number 4, gives you examples of some combinations of factoring, where you have to common factor first and then try to factor the trinomial if possible. So here I would factor out a 2, which would leave me with x squared plus 13x plus 30. And then I can further factor this into x plus 10 and x plus 3. 10. The next thing that I would do here is I'm going to factor out 3x from each term. That will leave me with x squared minus x and then minus 20. Now I'm looking for two numbers that add to minus 1 and multiply to minus 20. Those two numbers are minus 5 and positive 4. Now I have a fully factored equation. My third example here, I can common factor out a 3 from each of those terms. That's going to leave me with x squared minus 4xy is 32. So now I'm looking for two numbers that multiply to 32 and add to 4. Those two numbers are going to be x minus 8y and then x plus 4y. I can double check because my last term will end up being minus 32y squared, and my inner term is going to be minus 8xy plus 4xy, which will give me minus 4xy. Example D, now I'm going to common factor out 2y from each of those terms. That's going to leave me with x squared plus 2x minus 24. I can further simplify that into x plus 6 and x minus 4. My final example here is a's and b's. What I would start with here is factoring out a 4, leaving me with a squared b squared minus 3ab minus 10. I can further simplify that by looking for two numbers that multiply to minus 10 and add to minus 3. Those two numbers are going to be minus 5 and positive 2. That concludes the examples for factoring simple trinomials.